Hello, this is Miss Dagenford, and we are going to look at today how we organize, how we build a diagram that allows us to organize the information that we've been learning. And so, yesterday in class, in our connection day, you were taking a look at the three different domains, and you saw the branching diagram that they used in that video. Now, I want you to think back over the previous unit that we did with creation and evolution, and remember the fact that I showed you these diagrams at the end of the unit. And the point of these diagrams was to represent these models, these images of representing speciation events. And every branch that you see in this tree represents a speciation event, and therefore an original population diverging into two populations, becoming two species. Now, that original population would be the common ancestor of those two species. Now, remember that even the strictest interpretations, young Earth, they do use these same diagrams. They just limit them. So remember, they have separate trees over that. Whether or not you agree with that or not, that's what they do. So they use the same techniques as for organizing these. They study the characteristics, they study the DNA. What they don't do is connect the trunks together. They would trim the trunk and keep different trees. However, the way they make the trees are the same. They're going to look at shared characteristics. They're going to look at DNA. They're also going to use these diagrams to illustrate what happens over time. So let's take a look at how we do this. Now, the first way or the first tree diagram that we'll look at, and they're very similar, would be a cladogram. The other one is called a phylogenetic tree. They are very similar in intent and in a lot of the same applications. One is a little bit more intentional about spacing for time, whereas the cladogram is a little bit more just representative of relationships. So cladograms can point to the side or they can point up. But bottom line, what they both have is a root or the bottom. Think of like a trunk. And then what you see is that the lines diverge. Now, as the lines diverge, that represents a speciation event. And where you see a branching, that's called a node. That would represent that population diverging into two species. And so we would have that ancestral species. Now, what we would say is that because there's something that caused them to separate, then whereas before they had a shared characteristic, when they diverge, they suddenly have two different characteristics. So we can think of, at our most fundamental level, if you think of reptiles and mammals, reptiles are not able to maintain their body temperature. Mammals can, but they both are four-legged animals. And so they have a common characteristic, the four legs, but then they have a split and you have cold-blooded versus warm-blooded. And so that would be how we use our branches to illustrate that. Now you're going to watch a video from Bozeman Biology. He explains this very well. And as he explains it, I made a kind of the same thing you see on the video, just so you can try your hand at it. And so you, as a class, can pause the video at specific points, and you guys can discuss where you think you should place these pictures in the cladogram. And you can also follow along and make your record of what you guys decide. So let me show you with these imaginary creatures. So let's go over, and then again, you guys can hit pause the video, discuss as a class what should go next. So our little imaginary critters, cute little guys, little blobs of blue. And so we have A, B, C, and D. A, notice, is very simple. It's just this round organism with only eyes. Now he's the simplest animal. So we're going to put him at the bottom of our tree. And so let's think about what would go next in our grouping. One helpful thing to think about is what do they have in common and what do they have different? What characteristics do they differ in? And so think about, we've got B, which does not have legs, but he has eye stalks, spines. C has legs, no spines, but eye stalks. And then this little guy has eye stalks, legs, and eyelashes. So go ahead and hit pause. And maybe you think, okay, well, these guys, D and C, have the most uh, 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 characteristics. So they're going to be a little different from A. Who's the closest to A? Well, B is the closest to A. But let's figure out how he differs. Well, he differs because he has eye stalks. So what we're going to do is we're going to put that characteristic before the split. And we're going to say, okay, here's this little critter. And then there's eye stalks and everybody after this. So remember, the arrow is pointing in through time. So everybody after that box should have eye stalks. Now B has spines. Nobody else has spines. So we can move that characteristic there. And notice, again, if you follow the arrow, this little guy has spines. Nobody else does. So again, let's think about what we're going to see. So think about how you would arrange them. Hit pause if you need to. And over the years, what most people agree, and that would be that if we put C and D here, and then we would put eyelashes there, and legs below that branch point. And then if we have done this correctly, we would find everything makes sense. Where this character is legs, everybody after that character should have legs. Let's check. D has legs, C has legs. Where we have eye stalks, everybody after that should have eye stalks. Eye stalk, eye stalks, eye stalks. Very good. Now, one quick word about these cladograms. You want to treat these nodes as revolvable, like a mobile, like a child's mobile. And so if you thought it should be like this, and let me get rid of that legs, that's confusing things. If you thought it could be like this, well, you're right too, because it still shows an accurate relationship between all of the characteristics and all of the organisms. D is the only one with eyelashes. The way we put the characteristics there, that works. Here we have D. You follow the arrow. He's the only one that has eyelashes. Legs, both C and D have legs. B is the only one that has spines. And B, C, and D all have eye stalks. Now you're going to do a couple of practice problems in a classwork assignment, and then you're going to really be challenged with an online lab that has you do these. It's one of my favorite activities to do. It's like a game, and I think it's a lot of fun. So hopefully you will too. So hopefully this will get you started on your homework.